I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at how to rewrite the equation of a hyperbola into standard form by completing the square. So in order to graph a hyperbola, what we have been looking for is this form, x minus h squared over a squared minus y minus k squared over b squared equals 1, or maybe swapping those numerators around. But we definitely don't have that here. So get rid of that. We can do this by completing the square. So first, for the terms containing x, I'll factor out a common 4, x squared minus 4x, and I'll leave some space to complete the square. I'm going to add the magic number. For the terms containing y, I'll factor out the negative 9, and that gives me y squared plus 2y, leave some space, equals 29. Now to complete the square, half of negative 4 is negative 2, squared is 4. So I'm going to add 4 inside the parentheses here. But I'm really adding 4 times 4 because of the 4 that's out in front of the parentheses. Same idea for the y terms. Half of 2 is 1. 1 squared is 1. So I'm going to add 1 in the parentheses. But because of the negative 9 in front, I really have negative 9 times 1 on the left. I need the same thing on the right, minus 9 times 1. Factor the trinomials. This is 4 times x minus 2 squared minus 9 times y plus 1 squared equals 29 plus 16 minus 9. And that equals 36. So we're getting closer. To finish this off, I need a 1 on the right-hand side. I can do that by dividing by 36 on both sides of the equation. 4 goes into 36 9 times, so we've got x minus 2, sorry about that, x minus 2 squared over 9 minus 9 goes into 36 4 times, y plus 1 squared over 4 equals 1. Now I've got everything that I need to graph this hyperbola. It's in the right form. First, I've got x squared minus y squared. That means that it opens left and right. The center is 2, negative 1, because h equals 2 and k equals negative 1. A squared equals 9, so a equals 3. That means we're going to move 3 left or right. And because it opens left and right, those will help us to find our vertices. B squared equals 4, so b equals 2. That means we're going to move up and down by 2. Looks like I have a big smiley face here. It's just a weird reflection. There, that's better. It was just off the iPad. Let's see, what else do we need? C equals the square root of a squared plus b squared. That's the square root of 13. We've done that one a few times now. That's 3.6, I believe. Yeah, 3.6. So I've got everything I need to start this graph. The center is at 2, negative 1. Because it opens left or right, I'm going to put the vertices on by moving 3 to the right and 3 to the left. To help draw the box, I move up by 2 and down by 2. Draw the box. Draw the asymptotes through the corners of the box and through the center of the hyperbola. And then again, since this one opens left and right, something like this, getting closer and closer to the asymptotes as we move out. The vertices, the center was 2, -1. The vertices, we moved that by 3. So add 3 to x and subtract 3 from x. For the foci, we're going to add that square root of 13 to x. 2 plus root 13, 2 minus root 13. And again, because the square root of 13 is about 3.6, this is about 5.6, -1, and this one is about -1.6, -1. And we can add those they would have been about there. All right, so that's it for this one. We've got one more video to go with, I'm sorry, I didn't do the domain and range. The domain, let me add that up here. The domain, as we look from left to right, is going to be -∞, comma, -1, union, and then it starts up again at 5. 5, comma, infinity. The range is all real numbers. Right. In the next and last video for hyperbolas, we're going to take a look at eccentricity for hyperbolas.